Okay, all right, good morning everybody. So for today we will look into example 7.1. Okay, so this one we have a dentist, okay, uses a small mirror attached to a thin rod, okay, to examine one of your teeth when the tooth is 1.2 cm, okay, so this one 1.2 cm in front of the mirror. The image, it forms 9.25 cm behind the mirror. Okay, so basically you have two information over here lah. Okay, so 1.2 cm in front of the mirror, which will be the object distance, okay, u. Okay, and then this one we have image forms 9.25 from behind the mirror. Okay, okay, so which will be the image distance lah. Okay, so for this one, okay, for A, they want you to determine the focal length of the mirror and state the type of mirror that is being used, okay, and then B, the magnification. Okay, so we list out the information first. Okay, so U, okay, you have a real object. Okay, V, we will have negative value, okay, because the image form behind the mirror, so that means we will have an virtual image. Okay, so since we have u and v, okay, so what you can do is that by applying the mirror equation, okay, 1 over f, which is equivalent to 1 over u plus 1 over v. So replacing the value, okay, so we will end up with f, which will be the focal length. Okay, since we get a positive value over here for the focal length, that means we have a concave mirror, okay, or concave reflector lah. Okay, and then for magnification, okay, we apply the equation for magnification where m will be equivalent to negative v over u. Okay, so replacing the value, we will end up with 7.71. Okay, so this one we have value which is greater than 1. Okay, if the value is greater than 1, so that means we have an magnified image. Okay, if it is less than 1, that means we have a diminished image. Okay, and then the final value, if the final value of m over here is positive 7, okay, positive 7, that means we have upright image. Okay, so if you have a negative value, that means we have an inverted image lah. Okay, so basically the final value, okay, if you get a positive value, so that means you have an upright image. Okay, all right, next let us look into example 7.2. Okay, so for example 7.2, you have an upright image from 20.5 cm, okay, from the real object, okay, by using the spherical mirror, and then the image height is given, okay, 1/4 of the object height. Okay, so these are the two information given lah. Okay, okay, and then for question A, where should the mirror be placed relative to the object? Okay, so that means they want you to determine the object distance u, okay, and then calculate the radius of the curvature of the mirror and describe the type of mirror, and then sketch the label diagram, okay, to show the formation of image. Okay, now for the information given, okay, height of image is 1/4, okay, that means quarter of the object, height of the object. So over here we use subscript I, image, and then this one subscript O for object lah. Okay, so this is one information that we have. Okay, what we can do is that we can draw a diagram lah, okay, to to simplify the question. Okay, so according to the question, okay, the image forms 20.5 cm from the object. Okay, so it's some sort look like this lah. Okay, so where you have a mirror in between. Okay, so this is your object. Okay, and then you have an image over here where the 0.5 is the distance from your object to image. Okay, so that means the relationship will be u plus with v, you will end up with 20.5. Okay. Okay, so from the figure, okay, so this one over here, just take the modulus value lah. Okay, all right, because basically for virtual image we will have negative value, but since the distance is measured from object to image, okay, just take the magnitude only. Okay, no need to insert the sign convention. Okay, which will be 20.5. Okay, and then by using a magnification, okay, which will be equivalent to ratio of v over u. Okay, and then we know that the height of the image, okay, a quarter from the object. Okay, then what we can do is that can rearrange, okay, in terms of v, okay, which you end up with 0.25 u. Okay, so what you can do is that replace into equation 1, okay, and then final answer we will end up with 16.4 centimeter. So this will be the object distance lah. Okay, so that means the mirror should be placed 16.4 cm from the object. Okay. Okay, next by using the mirror equation, okay, so we know that the equation v is equivalent to negative 0.25 u, right? Okay, so just replace in to determine the value of the focal length. Okay, so once we obtain the value of focal length, we can determine the radius lah. Okay, where f will be equivalent to r over 2. Okay, so therefore we will end up with 10.9. Okay, so for the type of the mirror, okay, so focal length over here we get negative value. Okay, so what does a negative sign indicate? Okay, so when we have a negative focal length, so that means we have an convex mirror lah. Okay, over here we have a convex mirror because we end up with a negative focal length. Okay, and then for the diagram, okay, so we have a convex lens. Okay, u value already determined, so just sketch the image lah. Okay, so for convex lens, okay, we only have one characteristic, it doesn't matter lah. Okay, where you put your object, you will always end up with the same characteristic. Okay, so incident ray, reflected, okay, diverge away from the focal length. Okay, and then another line toward the center of the circle, okay, will be reflected back, so you will have an image formed over here lah. Okay, so that means you have an upright and diminished image lah over here. Okay, so another thing is that when we have an upright virtual but diminished image, okay, so that means we always have an, okay, convex reflector lah. Okay, that is one characteristic. Okay, all right, next look into example 7.3. so this one you have a person, okay, 1.6 meter height, okay, that means the height of the object lah. Okay, stands 0.6 meter from the surface of a hanging shiny globe. Okay, so that means this one 0.6 will be your object distance. Okay, and then if the diameter of the globe is given as 18 centimeter, where is the image of the person relative to the surface? Okay, so they wanted to determine the image distance lah. Okay, and then B, how tall is the person's image? Okay, height of the image, and then the characteristic. Okay, so height of the object, okay, object distance. So to simplify, maybe what we can do is that we can just sketch a simple diagram. So this one we have a globe, so that means it will be a convex reflector lah. Okay, diverging reflector. So by looking into the question, okay, diameter given, So that means we can determine the radius lah. Okay, radius which will be equivalent to 0.09. Okay, from radius we can determine the focal length. Okay, so since it is an convex surface, okay, so that means the focal length will be negative lah. Okay, virtual focal length. So applying mirror equation, so what we can do is that straight away replace in 1 over f, which will end up with 2 over r. Okay, height of object given. Okay, so determine the image lah. Object distance given, determine the image distance. Okay, so which will end up with negative 0.042 meter. Okay, that means we get an virtual image. Okay, so the image will be located behind the surface. Okay, and then for the image height, okay, so what we can do is that we can use the magnification formula, ratio of V over U. Okay, so height of the object already given 1.6. Okay, this is the image distance, okay, over object distance. So determine the height of the image. So which will end up with 0.112, okay, or 11.2 centimeter lah. So the characteristic that we end up over here is that, okay, so if you look at the ratio of magnification, you will negative V over U. So negative cancel off, that means you will get a positive magnification, right? Okay, so positive magnification, that means you have an upright image. Okay, and then the ratio of 0.042 over 0.6, that means you get less than 1. So that means you will get an diminished image. Okay, so whenever we have a virtual image, we have an upright image lah. Okay, so this one M negative, okay, cancel off, you have an upright image. Okay, so we have virtual, upright, okay, and diminished image. And then the image forms behind the surface. Okay. Alright. Next, let us look into example 7.4. Okay, so this one you have a shaving or a makeup mirror. Okay, forms an image of a light bulb on a wall of a bathroom. Okay, so this one you have a image formed on a wall. That means we have an real image. Okay, so that means we have a real image. Okay, that is 3.5 meter from the mirror. Okay, so that means 3.5 meter will be the image distance. Okay, and then the height of the bulb is given 8 mm, and then height of image is 40 centimeter. Okay, height of the bulb, height of the bulb, so that means this will be your object. Okay, and then image given as 40 centimeter. So that means by reading at the description, okay, we have a real image. Okay, real image because it's formed on a wall. Okay, and then the bulb 8 mm, and then you have an image which is 40 centimeter. So that means you have real and magnified image, right? Okay, so this one they wanted to form a sketch a label ray diagram. Okay, so for the sketching purpose, okay, we need to do estimation lah based on the description given. Okay, where do you think your object is actually located? So this one you need to go through the sketching that you have done before lah. Okay, so basically if you place value of your object distance greater than C, you will end up with diminished image. Equal to C, you will end up with same size, right? So that means your object is now placed somewhere between your F and C. Okay, so based on the information, okay, so ray diagram, so your object should be placed somewhere lah in between C and F. Okay, so this is 8 mm, height of the object. Okay, draw the ray diagram, so which will end up with the image over here lah, real image. Okay, real and magnified. Okay, for question B. Okay, so for B, they wanted to calculate the position of the bulb from the pole of the mirror. So that means they wanted to determine the object distance lah. Okay, and then the focal length f. Okay. Alright, so what we can do is that we can use the magnification. Okay, height of the image over height of the object. Okay, image distance given, object distance unknown, determine the object distance first. Okay, and then once we have the object distance, okay, so we can replace in mirror equation. Okay, determine the value of focal length lah. Okay, so which we end up with positive. Okay, so positive focal length, so that means we have an concave reflector over here. Okay, alright, so this is done ready for the first part. Okay, for concave reflector. Okay, so go through with all the example. Okay, and then do some revision, try to relate with your drawing lah. Okay, drawing, and then go through with the equation and problem solving. Okay, so that's all for today. Have a nice day.